Hello, we are discussing about GATE 2006 ECE paper. We are going to find output voltage expression for the given circuit, and it is given that all capacitors are initially uncharged. So voltage across the capacitors at t is equal to 0 is 0 volts. This is first condition is given, and second condition is given as Vi is equal to Vi of t is equal to 10 times of u of t. 10 times of u of t is unit step of u of t means unit step. 10 times of u of step is 10 times step. So simply it is 10 volts step. So 10 volt step means at t is equal to 0 you are applying a 10 volt step, that means 10 volts constant. So this will be treated as 10 volts DC. Vi means 10 volts DC we are applying starting from t is equal to 0. As you are applying a DC voltage, okay, for this circuit, capacitors gets charged towards that voltage. Okay, so here output voltage V0 of t is same as voltage across this 4 microfarad capacitors. Say for example this is R1 and it is C1. This is R2 and C2 combination. So V0 of t is nothing but Vc2 of t, voltage across capacitor C2. Okay, so you must get voltage across capacitor in time domain. That is the required answer. So voltage across a capacitor changes exponentially with respect to time constant. Okay, that can be known, that can be written at any point of time if you know the initial value and final value of that capacitor. So already we know initial value of that capacitor, that is Vc at t is equal to 0 is 0 volts. Next what we require is Vc at final value, that is at t is equal to infinity. So voltage across capacitor at any time, voltage across capacitor at any time can be written as Vc of t, which is equal to Vc at infinity plus Vc at 0 minus Vc at infinity into e power minus t by tau. Vc at 0 is already given, it is 0 volts. Vc at infinity is capacitor voltage at t is equal to infinity. That means Vc of t under steady state. Under steady state, capacitor act as open circuits. So both the capacitors C1 and C2 act as open circuit under steady state. Then the circuit is going to be simply looking like a resistor combination, that is looks like a voltage divider with 10 volts DC at input and V0 of t is the voltage across 4 kilo ohm resistor, that is R2, and this is 1K. So by using voltage divider we can write it as 4 by 4 plus 1 into 10 volts, which is nothing but 8 volts. So V0 of t at t is equal to infinity is 8 volts. So we have calculated this value, that is 8 volts, and Vc of 0 is 0 volts, and what we require is tau. Tau is equal to, called as time constant. Time constant is a product of equivalent resistance and equivalent capacitance across the terminals of interest. So across this output terminals, okay, what is R equivalent and what is C equivalent? So tau is written as R equivalent into C equivalent. R equivalent can be calculated by short circuiting the input voltage and removing the capacitors. Because we are only calculating the equivalent resistance across these two terminals, we will consider resistances and we will ignore all other elements. So nullifying the voltage sources and current sources if present, our circuit consisting of only one voltage source, that is 10 volts DC. So you must make short circuit. You must make short circuit of input. So you are making it as short circuiting the input voltage and you are removing these capacitors. Then equivalent resistance between these two terminals looks like 1K and 4K are in parallel. So R equivalent can be written as 1K in parallel with 4K. And next, C equivalent across these two terminals can be calculated by again short circuiting the input voltage and removing the resistors. If you remove the resistors and short circuiting this input voltage, it looks like capacitors are in parallel, C1 and C2 in parallel, and in parallel capacitors gets added. So you can write it as C1 plus C2. So that means 4 microfarad plus 1 microfarad. And time constant units are seconds. So this is 4 into 1 into 4. 1 into 4 is 1 into 1 parallel 4. 4 divided by 5 K plus into 4 plus 1 is 5 micro. So total is going to be 5 get cancels. It will be equal to 4 milliseconds. Tau value is 4 milliseconds. Okay. Now Vc of t, voltage across capacitor C2 at any point of time, which is also called as V0 of t. That you can write from the expression 8 plus 0 minus 8 into e power minus t by 4 milliseconds. That means 8 into 1 minus e power minus t by 0.004 seconds. So this is the voltage. Final output voltage V0 of t is 8 into 1 minus e power minus t by 0.004 volts. So if you are going to write under steady state, okay, the right answer for this question is B. But under steady state V0 of t, that is V0 at t is equal to infinity. By that time all capacitors acts as open circuit, then you are going to get Vc at infinity as 8 volts. This 8 volts can be written as 8 times of u of t. 8 volts DC, which you can write it as 8 times of u of t. This will be the right answer if it is asked explicitly V0 of t under steady state. But it is not asked about under steady state, so C cannot be the answer. The right option for this question is B itself. Thank you.